Hello, everyone. My name is Jihye Kim. I'm a security researcher at the Code Research Institute at the University of the Bundeswehr, Munich. And I'm also the first attendee of the DNS-OARC. So, yes. And the work is also the early stage work. So I would very much welcome with any feedback or suggestions after the presentation. Then let me start my presentation. It's for the LLMs for DNS abuse detection. Is it promising or overhyped? So yes, LLMs are everywhere. New stories emerge every day, and people are testing them in almost every field we can imagine. And according to the Gartner's hype cycle, the LLMs and generative AIs are already passing through the peak of the inflated expectations, and it's currently at the throes of disillusionment stage, which means that the over expectation has been disappeared, and people are trying to use it in a more practical way. And when you search for the LLMs and DNS, we can already see lots of ongoing attempts that people are trying to use the LLMs for DNS to tackle the challenges. To introduce some state-of-the-art related work, the researchers are trying to find out the novel ways of DNS DDoS attacks by taking a pre-existing DNS attacks by an example and asking the model to elaborate it into the executable zone file configuration and then testing it into their labs. And by using this simple way, the researchers were able to find the 3 novel DNS DDoS attacks. And the another work that I'd like to introduce is called the survey paper. It's using the LLMs for DGA detection, and the domain is also the sequential and text-based. So yes, it can be the good input for the LLMs. And there are already lots of attempts using the transformer-based models, BERT-based models, and the specialized or scalable LLMs. So what we are trying to do is not just like, yeah, let's try because LLMs are popular. It's not like that. We have much more practical and reasonable reasons why DNS is a good input for LLMs. First, DNS is a symbolic and text-based, so it naturally fits very well with LLM tokenization. And second, DNS is human-readable, structurally complex enough, and also has rich real-world attack surface with diverse threats, including DDoS attacks, phishing, tunneling, cache poisoning, and so on. And lastly, for these reasons above, it could be a strong benchmark for the structural reasoning. From the opposite side, then why LLMs are good for DNS? First, LLMs enables the semantic context detection and also provide the prompt-based zero-shot and the few-shot generalization, which means that it detects very well with the unseen or the novel type of DNS attacks. And then it can also provide the explainability and the actionable response generation more easily via the natural language. So compared to the traditional machine learning or statistical approach, LLM-based approach have much more advantages in terms of the input, adaptability, explainability, and so on. Then how can LLMs be effectively used in regard to DNS? So we have thought of multiple promising ways, especially in regard to DNS traffic. So we can develop the generator LLM that can create the synthetic DNS attack traffic. And we might develop the detector LLM that can detect and explain the DNS attack traffic. And from the opposite side, there could be a deceiver LLM that can try to deceive and confuse the detector with the adversarial traffic, which means benign-looking attack traffic. And our current focus and the ultimate goal is to develop the detector LLM more trustworthy and performant. So for this, we start from the building the DNS abuse taxonomy. So DNS can be both as tool or the target for DDoS attacks, and we mainly categorize this into 5 main types of DDoS attacks, starting from the flooding to DNSSEC abuse. And then this is the detailed description of each attack type. So for example, a flooding attack is sending the excessive DNS queries and targeting the DNS itself. So it's targeting the DNS and direct DDoS vector. And the amplification is using the resolvers to send and amplify the traffic. So it's the indirect DDoS and using the DNS as tools. And certain attack can be overlapping, which means it can be flooding as well as the amplification. But we thought that this is the reasonable category for each attack. And after that, we categorize each class into multiple subclasses. For example, in the case of the flooding attack, it can start from the simple query flooding, the response flooding, and it can be much more complicated, like the NX domain flooding, water torture, slow drip, and so on. And based on this taxonomy, we try to analyze each attack type in more detail. For example, the NX domain flooding has key characteristics that have the random, non-existent subdomains. And the traffic features are like this. It should have high NX domain ratio, query rate and entropy, the QName count, and so on. And based on these features, we analyze and judge the traffic generation, LLM detectability, deception risk. And this abuse taxonomy will serve as the knowledge base of our system. So this is the overall the flow of our system, starting from the data collection to the input processing, and then finally it will provide the results using the Gradio Web UI. And I will explain each functionality in more detail at later slides. So from the LLM perspective, I think every task can be broken down into 3 levels: the input, model, and output. So it's just like the mathematical problem to figure out the proper parameters and the features or the type of the input to solve our problem more efficiently. So which data sets or features will be used, which LLM models, how we will fit the data, and what you want to back as the result. Starting from the input, we plan to use the data sets from the multiple sources for the reliability. And for the public data sets, we use the open internet data sets as the ground baseline for the benign traffic, and also use the open source attack data sets like the honeypot for the attack traffic. And for the synthetic attack data sets, we plan to use the well-known traffic generators, and also will augment using the LLMs. And while working on this direction, actually, we also realized that it's quite difficult to get the reliable DNS DDoS attack datasets that includes the diverse types of attacks. So yeah, we just decided then, let's build by ourselves. So we are currently building the synthetic DNS attack traffic generation framework, and also plan to evaluate whether the LLM augmentation for generating traffic is feasible. And after collecting the data sets, this will pass through the pipeline, starting from the DNS extractor. So the DNS extractor will extract the features from the FICAP file, and then the compute features will compute and calculate the features that can be representative of each traffic. And there are 2 modes, the packet modes and window modes. So we can see the per packet behavior and the per file behavior, as well as the per window behavior by using the sliding window concept. And then the LLM formatter will change this format into the JSON-L for the LLM input. And for the model selection, it's also quite difficult to choose the right model because there are lots of diverse types of models. Since we need the classification, explanation, and generation. First, we start with the encoder and decoder type, since it can provide all the functionalities that we want to use. And among the encoder and decoder types, we chose the T5, the text-to-text transfer transformer, as a prototype. Since the T5 model is optimized to process the text-based datasets and also has the less parameters and less overhead computational cost compared to the other encoder and decoder model. And yeah, these are the scripts for training and inference for the T5 model. And as a high level, T5 base model has 12 layers of the encoder and decoder, and the encoder will ingest and read the formatted DNS log and model the global DNS behaviors. Then the decoder will cross-attend to the encoder's context and eventually can make the output as the JSON token sequence that can be human readable. And as I described before, the DNS attack taxonomy will work as the knowledge base for the LLM inference. And we also plan to connect this with the RAG concept so that you can provide the up-to-date data reasoning from the RFCs and the recent attack reports and attack papers, the research papers. This whole pipeline will be connected to the Gradio Web UI, and the users can read the results from the summary card, which includes the information like the class, subclass, score, explanation, and the mitigation. And the labeled CSV file will be provided as well. And lastly, this will be also connected to the monitoring services, the Grafana and Prometheus. So we can see the metrics and features in the visualized platform so that the users can get to know the health status and the anomaly monitoring. Okay, this is the current status of my research. And since it's still the early stage, so we have a bunch of items that we have to do in the future. As a short-term goal, we plan to benchmark with more diverse DNS datasets and also plan to compare with the other model families. And as a midterm goal, develop a synthetic and adversarial traffic framework. And as a long-term goal, if possible, this can be towards the operator-grade deployment. Okay, so this is the end of my presentation. And I've also prepared a simple demo. And not to make any unexpected errors or mistakes, I actually already prepared for the pre-recorded video. So I'd really appreciate it if you can play the video. In this demo, we will showcase a simple DNS abuse detector. The front end is built with a Gradio web interface and light custom CSS. When we upload the PK file and run the detection, the pipeline automatically performs the multiple steps and all the results appear inside the summary card. On the left, we can choose a model, what we use, from either a local model directory or Hugging Face model ID. And these are the generation settings for the device and the model. For example, the number of the prompts, the sample packets, tokens, and so on. Now, we will run a few pickups to show the different DNS abuse detection. For the sample2 file, this file is classified to the response flooding due to its elevated response rate over sources. Next one. This one has been classified to the water torture because of its many uniques and high DNS domains. And here in label mix, you can see the label distribution. The water torture portion dominates, while the response flooding pattern is also a small slice. So this chart visualizes these proportions of the traffic. And below the label mix, there are two download options. The results pretty TXT and features labeled CSV. And this file contains the extracted features such as QName, the R code, the entropy, NX domain ratio, and so on. And lastly, these metrics are exported to the Prometheus and the Grafana monitoring services. So the metrics appear on the dashboard for the quick health and detection status monitoring. Overall, this demo shows an end-to-end pipeline from the raw PCAP to detection, to mitigation, and monitoring. Yes, this is the end of my presentation, and thank you very much for listening.
Hi, we are open for questions.
Hi, John Todd from Quad9. Were your test models initially for recursive data or authoritative data, or did you not distinguish between the two? In other words, is it effective for both types of DNS data sets?
Yes, currently we just have used the benign traffic for the open data sets, and that is actually the data sets for the authoritative DNS servers.
Okay.
But I think at least it can show the normal behavior, the normal format of the DNS traffic. And as for the attack traffic, we just have used from the end user to the normal resolver. Yes, okay. The recursive resolver. Yes.
Okay, thank you.
Klaus Darillion from nick.at. So we have plenty of PCAPs lying around from our authoritative servers. So what will it really, what do I have to do to run those analyses also against my PCAPs? How much effort would it be to, or all your stuff, is it open sourced, or is it a commercial product you're doing here, or is it just research yet?
You mean in the case of demo, right?
Yeah, so not a demo, I want to use it to analyze my PCAP.
Yes. So it's still not the open source. And I think I mainly explained the overall pipeline and the framework of our system, but the traffic data set should be much more diverse, since I currently only tested with the diverse types of the flooding attacks, not the other types. And to make it to be more performant with other attack types, I think we need more training and also need to get the data sets from other sources as well. Yeah, so it's still not possible. Yes.
Thanks. Any more questions? I have one question, Jihye. Right now, looks like you're working off packet captures of the traffic. Do you expect to be able to run this near real time with live queries?
That's a good question. Actually, one of the disadvantages of using the LLMs is that it has high computational cost and also has the latency that is not very fit well as a real-time mitigation. And if the PK file, the size of the PK file is very large, then I think it can cause the longer delay as well. So I think it's a still the open question. Yes, have to figure out how to make the balance and how to compensate this trade-off by guaranteeing the performance and lowering the latency.
Okay, so are you saying that you do plan to look at basically seeing if this can work in real time? It is a goal.
Yes, that's the ideal goal at this moment. Yes, but still not employed yet.
Any more questions? All right. Thank you very much, Jihye.